Okay, we're looking at problem 14, it's an extension of problem 13. And in this case, we're going to be solving the members on the left side of the truss. So we have a member here, and a member here, and a member here. And we have member GH, member CH, and member CD. And so what we're going to do first is do a sum of forces in the X. And that's going to give us minus CD minus CHH minus GHH, and all of that will be equal to 0. So solving sum of forces in Y, we're going to get minus CHV, we're going to have plus GHV plus 14 minus 8, 0, and we get CHV plus GHV is equal to minus 6. So we don't get a whole lot of resolution out of that. Let's try a moment. Take a moment. Now remember, we can take moments pretty much anywhere. We've got two obvious really good places, one here at H, which would resolve CD, and one here at C, which would help us to resolve G. So I'm going to take a moment at H first. And at H, while we're up here, it's going to knock out 14 and CH and GH. So we're looking at 10 distance here times 8 kips, positive rotation, plus 10 CD is equal to 0. CD is a negative 80 divided by 10 gives us a negative 8 kips, and that will be compression. So it's telling us it's not a tension member, it's compression. Okay, that's going to help us eventually, but right now it's not doing much. So what I want to do is take another moment. So I'm going to take another moment. Now, I'm going to take a moment here at C, and by doing that, I'm going to knock out CD, CH, and I'm going to use transmissibility and bring this guy up so his vertical component is coming through my moment, but I'm left with the horizontal. So what I'm going to get out of this is the horizontal component of CHH. So what we're going to have there is going to be minus 10 times 14, so 10 feet over, or 10 meters over, 14 kilonewtons. And then we have plus 20 over times 8. And then we're going to have up here, we're going to have 10 plus the 5.77. So that's 15.77 GHH is equal to 0. So by doing the resolution of this, we'll be able to solve GHH. It's going to be equal to a minus 20. And you bring those guys over, divided by a minus 15.77 gives me 1.2 positive. So what that's telling me is that this will be a tension member. So utilizing my geometric relationship, that can tell me that GHV is to 5.77 as 1.27. Units of force is to 10. And GHV, therefore, will be 0.73. So knowing those two things, we can solve GH. GH is 1.27 squared plus 0.73 squared. That will give me 1.46 of tension. Okay, so that is a tension member. So everything else now should be pretty well resolved. Let's see what we have. We need GH. So, or CHV. So we can plug GHV, which is the 7.3 up here. When we do that, we get CHV is equal to 6.73. So when that comes over, it comes over, it adds, and you got that down. Okay, so knowing CHV is 45, so that also means, therefore, that is equal to CHH, so they're equal. Okay, so one thing we can do is a check. We can plug stuff back into here. So we know if we've taken 8, negative 8 plugs into that, that becomes an 8. CH is negative 6.73. And GHH is 1.27. And when we add those should equal to 0. And that's a check. So the only thing we need to do now is get our CH value, 6.73 squared plus 6.73 squared, square root, gives us 9.52 tension. So tension, and compression. And that one's a little bit more involved because of the angles that you have to deal with. So you can end up taking maybe 2 moments, sometimes 3 possibly. But that's a good way to solve that.